Hi there, in this video we will continue our analysis of mutually exclusive projects, and previously we have done 4 cases. This is the 5th one in which we will analyze the multi-purpose projects. Definitely the multi-purpose projects will be those which will come with more than one objectives, and then how we can choose among these projects or between these projects. This is the thing that we will address here with the help of a certain real life example. Primarily, we know that project design can include one group of purposes, and it is mutually exclusive alternative to another project which can have a different group of purposes. So there are 2 projects, for example, and they have their own groups of purposes. That's why we call them multi-purpose projects. Similar projects, they are found in river basin projects or other rural development projects where the need for development is quite high and many purposes can be served with one project. So river basin project can have multiple purposes, for example flood control, irrigation, or power generation. There are many purposes that we can get from such a project. Then we have a group of related goods and services more cheaply or from a single project, and that can be compared with a multiple set of projects that are serving those benefits or purposes separately. So we can come up with a multi-purpose project that can be more desirable as compared to many projects that address those benefits or objectives individually. This is why a multi-purpose project can be a better option in certain situations. There is a danger for many beneficial purposes to get overlooked. For example, flood control is a long-term objective that might be overlooked if we are focusing on short-term objectives. So long-term objectives should also be included, and that multiple purpose project should also try to include the long-term objectives. And when this happens, the overall economic return and thus other benefits or objectives, they can also be omitted. That is, for example, irrigation, etc. So let us consider an example that will make this clear. Let us see, there are 2 basically alternatives that we have, and they are multi-purpose projects because there are benefits, that is flood control, irrigation, and power generation. So there are 3 benefits or objectives that we are trying to achieve. Similar holds here. However, in this case, irrigation has a certain value for this set of years, that is 4 till 100th year. However, you can see here the irrigation has no value because the irrigation is not targeted in this project. So this is the difference between these 2 tables. The second column definitely is the cost, and it is without irrigation. This is why we make it WOI, and this is with irrigation. This is why it is positive and greater than that of previous values that are without irrigation. Another thing is the presence of constant cost and benefits during this time, that is from 4th year till 100th year. This is why we have an overall value here, and we will use the annuity factors here. This is something we have done before, so we can easily do it. Now the net benefits, they can be found by taking the difference, and here we are, 0 minus 2456 will give us the net benefits, and again net benefits, and so on. So this is the overall value which is here. Definitely it's a negative value, an undesirable thing, but we are not going to rely on the undiscounted net benefits. We will bring the discounting factor, and then we will do this. This is 2.50, and this is the NPV at 2.50 discount rate. So we are going to use this discount rate, another discount rate, another discount rate. A few discount rates are used. We can use other discount rates as well, but we are using those discount rates that are going to lead us to the desired results. Now the NPVs are found here, here and here. At 5% becomes negative until 4% remains positive. When we talk about the irrigation, we have NPV with irrigation, and for the first two possibilities it is positive, and again for the third possibility it is negative. Now these are the two values that we cannot compare straight away, because in this case irrigation benefits are there and here the irrigation benefits are missing. And again we have the costs that are different because of the without irrigation possibility and with irrigation possibility. So for this we can find out the difference of the two possibilities, and here we are, the years they are mentioned as they were before. The net benefits without irrigation and with irrigation are mentioned in these two columns. Then we have taken the difference of the two and we have a negative value as the sum of the two. Then we use the discounting factor at 2.5 and 4 and 5 and find the NPV by multiplying the differential of the two net benefits. We find these values. So we see that for the first possibility of the discount rate it is positive, but it turns negative here and there. So we know that the gross over discount rate is somewhere in between 2.5 and 4%. Before we calculate that and make an NPV profile, let us visualize this project, because this can be misleading because it is starting from 4 and going to 100 with the same values for all those years. So here we are, this table is made in which we mention all those values. As you can see, for the first 3 years the values are varying, but afterwards with irrigation and without irrigation and the difference of the two, they are giving us the same values for all the remaining years. Now we are going ahead, we have 50 years and then 60, 70, 80, 90 and then 100. For 100 years the values, they are constant. You can also find the IRR. We have done this, we have found the IRR and it is declining as we go ahead, and the NPV it is also found, and the highest NPV is with the without irrigation alternative. Now we are going to find out the crossover discount rate. For that we will develop the NPV profile. We have taken the difference of the discount rate, which is 0.5%, so 0, 0.5, 1.5, 2, 2.5 and it goes on up to 8.5. So this is the differential NPV column in which we have mentioned the NPVs after differencing the two rows columns, and these are those columns without and with NPV columns. So here we can see the NPV is positive, and here again it is positive but it is greater. So we can see the comparison is happening, but here somewhere they both turn negative. But we will depend on the differential NPV because it is showing the difference of the two, that is the irrigation and without irrigation possibility. So the difference gets analyzed and we should focus on the difference values in order to take the additional expenditure or look for the additional benefits. Now till this point, that is 3.5%, the NPV remains positive, but as it reaches 4%, it becomes negative. So clearly we can see that irrigation alternative is superior till 3.5 somewhere there, and afterwards the without irrigation alternative becomes superior because now the value is minus, and since Wi is before Woi, it means that it is the additional net benefit of the with irrigation alternative. So if it is positive, it means that with irrigation alternative is producing desirable results. But after this, it starts generating undesirable results, and we move from with irrigation alternative to the without irrigation alternative. So the crossover discount rate should be somewhere in the middle of 3.5 and 4%. So for that we have done the calculations. When we look at the undiscounted net benefits, the irrigation alternative seems better, but definitely we do not rely on the undiscounted net benefits. We rely on the discounted versions. Before that, we should know the opportunity cost of capital. It is, for example, 12%. So NPV is found here without irrigation and with irrigation, and these are the two values. 2.5 and 2.5 is here. 2.5 is chosen by us as we use this value in the beginning, the very first discount rate. So irrigation is supported, this alternative, by using the NPV, because the NPV of the irrigation possibility is higher. When we consider their IRRs, the irrigation alternative again gets supported. But this is not what we should rely on, neither undiscounted nor NPV simple version nor IRR. We should depend on the crossover discount rate, and we can do that once we have found the differential of the two NPVs and it is equal to this. We just found it in the steps before, and crossover discount rate is 3.913%. When we compare it with the opportunity cost of capital, it is less. So it means that we should not depend on the with in irrigation alternative, because the opportunity cost of capital is greater and the additional value IRR, that is the crossover discount rate, is smaller. So the opportunity cost of capital is something superior and more rewarding, and this is why we let go the irrigation option and we go with the without irrigation option. Then we have NPV of the crossover discount rate with irrigation and without irrigation alternatives. They both give the same NPV, and this is understandable because at crossover discount rate both of them are equal. Then we have NPV of the differential. It should be equal to 0, and it is, and that's a good thing because the NPV should be equal to 0 at the crossover discount rate. So now we can say that crossover discount rate can be used to choose between two projects which have multiple purposes, and we have to choose between those two projects. This was the NPV profile that guided us about the crossover discount rate, and before that we listed all the years and saw that how the stream looks like for this multiple purpose example, and this was the difference of the two possibilities with and without irrigation. Their NPVs at different discount rates, and this was for with irrigation alternative, and this was for without irrigation alternative. Now this is how it looks like, and this was actually the comparison of the multi-purpose projects, which is under the umbrella of multi-purpose projects, and mutually exclusive projects are now complete because we have done all 5 cases. Thank you.